Hello, my name is Mukul Datta and I'm a final year BTech student of NIT Warangal. Today we will be talking about the concept of angle of repose, which is a class 11 physics chapter concept from the chapter Newton's laws of motion. Firstly, we will be going to the definition, then we will be moving towards the examples, then we will be deriving some expressions, and at the end we will be doing some numericals to understand the concept in a better way. So first, let's get familiar with the term angle of repose. What is angle of repose? Angle of repose means it is the maximum theta or maximum angle at which block or some object stays at rest in an inclined plane. What is inclined plane? Inclined plane means a plane which is inclined at a certain angle. Now, from this diagram that I have drawn, we can see I have taken our plane which is inclined at a angle theta. We have taken an object of mass m and we have drawn a free body diagram. Now, before understanding the free body diagram, I want to give you the example to understand the concept in a better way. So, let me take a laptop, a plane, a object on top of it, and gradually we will be increasing the theta. The moment we will be increasing the theta, the object will slide down. We will be observing this sliding motion of the object at the maximum theta. So first we give a smaller theta. The object is still at rest. Then if we increase the theta slightly, the object is still at rest. Then if we increase the theta a more slightly larger, the object started to slide. So with this example, we got some clarity about the concept of angle of repose. Now we will see this concept, the example that I have given just now with the free body diagram. I have taken the plane, I have kept the block of mass m. The plane will exert a normal reaction perpendicular upwards. The block will itself exert a weight downwards mg. So I have drawn normal reaction upwards and I have denoted it as n. Now I have gave the weight mg downwards and I have drawn the two components of mg cos theta and mg sin theta. Now what will resist the block from sliding? The friction, the limiting friction. So I have drawn the limiting friction backwards, the block which is opposite to the block which is resisting the block from sliding, and it is denoted as FL. Now FL is expressed as mu s n. Here n is normal. Okay. So now we will take three conditions, three cases where we will see the theta as small, theta as large, and theta where the block is just about to slip. So where now here we can see the concept with theta small. First case we will take the theta small. So at theta very small, the block is at rest. So now in the first case I have taken the theta very small. The block I have taken on an inclined plane and the block is at rest. Here the theta is very small, so the friction which is opposing is overtaking the mg sin theta which is acting this side and helping the block to slide. Now we can see the sin theta value in which the theta is very small decreases and the cos theta value increases in the case where the theta is very small. If we take an example where the theta value is 0, which is very small, then the sin 0 is 0 and cos 0 is 1. From this we can understand that theta at very small, the sin theta value decreases and the cos theta value increases. Now we will take the theta a larger value. Now with this example, here I have taken the block, a plane, and I have gave it a larger theta value. Now the block started to slide. So in the second case, we can see at the theta which is larger value, the block of mass m started to slide. When the theta is very large, then the sine theta value increases and the cos theta value decreases. Now a concept comes which is known as just about to slip condition. What is just about to slip? When the theta is very large, before it start to slide, that point is known as just about to slip condition. Here the block stays at rest and it is just about to slide. Now here the limiting friction acts backward and the mg sin theta acts frontward, and it is equal, the both value are equal, so the expression we take out is mg sin theta is equal to fl, and the theta where we get this type of case, that theta is known as angle of repose. We will take out this angle of repose with some derivations, with some mathematical expression. Now firstly, coming to the FBD diagram. Here in this FBD diagram, the normal is directly equal to the mg cos theta. So we have written mg cos theta is equal to normal in the first case. Now in the second case, we know that FL is equal to, the limiting friction is equal to mu s normal. So we have written this in the second case. Now this n we have put from the 1 and we have taken out the expression FL is equal to mu s mg cos theta. Now from this expression we are taking out the theta value, the theta r value. We will be taking out the theta r value. So firstly mg sin theta r is equal to FL. Now we will be putting all the expressions and mg will be cut down and we will be getting the mu s equal to tan theta r, where the theta r is equal to tan inverse mu s. From this we got the expression of theta r, the angle of repose we got from this expression with this derivation. Now we will be taking three conditions. A condition where the theta is less than theta r. What is theta r? Theta r is the angle of repose and the theta is the inclination we gave. Now the theta r is larger than the theta we have given, which is giving that it is the block, the first case where the block was in rest. So it is a rest condition. There is no sliding and it is a static friction which is equal to applied force. Now we will be going to the second case where the theta is equal to theta r, and that condition is known as just about to slide condition, and here it is limiting friction and FL is equal to mu s n. Now we will be going to the third case where the theta is larger than angle of repose. Here the sliding starts, the motion happens and kinetic friction occurs. Here the expression is FL equal to mu k n. Now from this concept we will be going to the numericals, we will be solving some examples and we will be understanding the concept in a better way. Now we will be diving into a problem which will be on the topic angle of repose, we are taking a 2 kg block inclined on a plane of 37-degree angle. Here the mu s is given as 0.4 and the mu k is given as 0.3. In this question, the question is divided into 3 parts. We have to find out the block is either in rest or motion. We have to calculate the frictional force and the acceleration the block is generating. So to solve this question, first of all we have to draw the FBD. So the applied force is acting in the direction of motion and the frictional force is acting backwards or the opposite side of the motion. So to calculate the frictional force, the limiting friction force, the formula is mu s n. Here the mu is given 0.4. We are taking m to 2 and g as 10 and the cos 37 value is 4/5. From this we have got limiting friction value as 6.4 Newton. Now we are taking out the applied force. Applied force is equal to mg sine theta. Here the theta value is 37 degree. We are putting all the values and we are getting a 12 Newton force applied. Now we can see the applied force is greater than the limiting friction. So from here we can conclude that the object will be in motion. Now let's dive into the second part of the question. In the second part, it is said that to calculate the frictional force. To calculate the frictional force is denoted as mu k mg cos theta. Now let me say why mu k? Because here the applied force is greater. So there will be a kinetic friction. So we have taken mu k here, mg cos theta. After putting all the values, we are getting an answer of 4.8. Now for taking out the acceleration, we will be drawing the FBD diagram of this block. We are taking the block on the plane of 2 kg mass and the angle is 37 degree. Now if we draw the FBD diagram, the block will be opposed by mu k mg cos theta. This is the frictional force that we got, kinetic frictional force that we got. Now the mg sin theta will act just to help the block to slide. So it is written here and an acceleration of a will be there and it is written as ma. Now after solving the free body diagram, we got that ma is equal to mg sin theta minus mu k mg cos theta. From here we have got the acceleration value as 3.6 meter per second square. So now this is the end of the video and thank you so much for watching it.